Welcome back with another video on this channel. I am Zahin Nazir, and today we're gonna do OWASP Top 10 2021. This is 5th video in this series. We will start today with the task 16, and the vulnerability we're gonna do is number 7, identification and authentication failure. So hopefully by the end of this video we'll have just one more video to go, and then we're gonna close this room. Let's continue with the task 16. Awesome. So we have somebody is trying to steal the confidential information from some file, as you can see, and by the pattern of this shirt here on the arm, he is some kind of criminal with a previous record. Okay. Authentication and session management constitute core components of the modern web applications. Authentication allows user to gain access to the web applications by verifying their identities. The most common form of authentication is using a username and password. Yes, username and password since computer is invented. A user would enter these credentials and the server would verify them. The server would then provide the user's browser with a session cookie if they are correct. A session cookie is needed because web servers use HTTPS to communicate, which is stateless. That is true, unless you are cookie or some kind of mechanism to manage the state of your application. Attaching session cookies means the server will know who is sending that data, sending what data, and who is sending the data. The server can then keep track of users' actions. That is true. If an attacker is able to find flaws in authentication mechanism, they might successfully gain access to other users' account. This would allow the attacker to access sensitive data depending on the purpose of the application. Some common flaws in authentication mechanisms include the following. Brute force attacks. If a web application uses usernames and passwords, an attacker can try to launch brute force attacks that allows them to guess the username and passwords using multiple authentication attempts. Use of weak credentials. Web applications should set strong password policies. If the applications allow user to set passwords such as password 1 or common passwords, an attacker can easily guess them and access user account. Yeah, that is true. But if you incorporate the multi-factor authentication, in that case it will be much harder to compromise the account, because you don't need to just guess the password, right password. You also need to guess the other factor as well. And after multiple guessing, if you are failed in either of them, the account will be blocked. So the user who is the victim in this case will be protected. Okay, so that's why people are moving away from just username and password, single factor authentication, to multi-factor authentication. Weak session cookies. Session cookies are how the server keeps track of the users. If session cookies contain predictable values, attackers can set their own session cookies and access users' account. There can be various mitigations for broken authentication mechanisms depending on the exact flaw. To avoid password guessing attacks, ensure the application enforces a strong password policy, and also make sure that the automated password guessing attack are minimized. For example, you can use some kind of captcha to minimize these attacks. To avoid brute force attacks, ensure that the application enforces an automatic lockout after a certain number of attempts. This would prevent an attacker from launching more brute force attacks. Implement multi-factor authentication. If a user has multiple authentication methods, for example using a username and password and receiving a code on their mobile device, it would be difficult for an attacker to get both the password and the code to access the account. Alright, I'm streak 2. Awesome. Task 17, identification and authentication failure practical. So we have practical here. So this is the website. Let me open it in my browser here on my attack box. Hopefully today it is a little bit slow. Okay, let's paste and go. Okay, for this example we will look at a logic flaw within the authentication mechanism. Many times what happens is that developers forget to sanitize the input username and password given by the user in the code of their application, which can make them vulnerable to attacks like SQL injection. However, we will focus on a vulnerability that happens because of a developer's mistake but is very easy to exploit. Re-registration of an existing user. Let's understand this with the help of an example. Say there is an existing user with the name admin and we want access to their account. So what we can do is try to re-register that username, but with slight modification. We will enter admin without the quotes. Notice the space at the start. Now when you enter that in the username field and enter other required information like email ID or password, submit that data, it will register a new user, but that user will have the same rights as admin account. The new user will also be able to see all the content presented under the user admin. That is something. To see this in action, go to the application, try to register with the Darren and his user name. You will see that the user already exists. So try to register space Darren instead, and you will see that you are now logged in and can see the content present only in Darren's account, which in our case is the flag that you need to retrieve. All right. So let's try Darren first. TryHackMe.com. Password is p@ws. Let's see. Oh, error. Let's try again. This time with space. TryHackMe.com. This is the password. User is registered successfully. Okay, so sign in. So here we go. This is our flag, and we are logged in as Darren. Awesome. Now try to do the same trick and see if you can log in as author. All right. ARTHUR. So basically what they are trying to do is email I'm trying to think of a scenario where this kind of attack will be presented, right? I mean, technically, even there is a space, the computer will treat it as a different user account, right? So how this basically, maybe there is a logical error where basically the permissions are loaded on runtime, but at that time he is basically sanitizing the user. That means if there is any space in the start or at the end, it is the developers are trimming it, and that's why at the end, even with the space in the start and the author at the end, once you trim it, the author will remain. Okay, so the computer or the program will load the authorization for author user here. I think this is how it should work. author. So here is the author. Should be able to log in. Invalid user or password. What is the flag that you found in the author's account? And did I register correctly? Yay! So this is our flag. Awesome. So we are done with this task. Let's move on to the next one. We are 10 minutes into the video, which is very good. So software and data integrity failures, which is task 18. What is integrity? When talking about integrity, we refer to the capacity we have to ascertain that a piece of data remains unmodified. Integrity is essential in cybersecurity as we care about maintaining important data free from unwanted or malicious modifications. For example, say you are downloading the latest installer for an application. How can you be sure that while downloading it, it wasn't modified in transit or somehow got damaged by it? Transmission error. There should be hash. To overcome this problem, we will often see a hash sent alongside the file so that you can prove that the file you downloaded kept its integrity and wasn't modified in transit. A hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading about hashing algorithms, you will often read about MD5. MD5 is not secure. SHA-1 is not secure. SHA-256 I think is still secure, or many other available options. Let's take WinSCP as an example to understand better how we can use hashes to check a file's integrity. If you go to their SourceForge repository, sure, let's go there. You will see that for each file available to download, there are some hashes published along. Let's see. Yeah, we can see that. For the Win, let me zoom in a bit. So for WinSCP-5.2.1.5 setup.exe, so we have hashes available for MD5, SHA, and SHA-256. I will go for SHA-256 because these are compromised, right? And they have for portable as well. They have provided the SHA. All right. We have seen this SHA. These hashes. These hashes were pre-calculated by creator of WinSCP so that you can check the file's integrity after downloading. If we download the WinSCP, this particular setup file, we can recalculate the hashes and compare them against the ones published in the SourceForge. To calculate the different hashes in the lineage, we can use the following commands. All right, so let's do that. Copy. Let me open it in here. All right, I will accept everything. And which file they are set up? Let's go with the exe setup. And in 5 seconds, the file will be downloaded to our attack box. Awesome. Yeah, all right. So let's calculate some hashes. Okay. This is in the root, right? Let's see if the file is available. Yeah, file is available. So let's go with the MD5 sum and then the name of the file. Here is the sum. Yeah, it is the same. Let's go with SHA-1. Again, name of the file. Here is the hash. What about SHA-256? Sum. name of the file, and here we go. It is a little bit longer than the other one, and it took a little bit of time to calculate it, right? Okay, since we got the same hashes, we can safely conclude that the file we downloaded is an exact copy of the ones on the website. Yes, that is true. All of them are matching. Software and data integrity failures. This vulnerability arises from a code or infrastructure that uses software or data without using any kind of integrity checks. Since no integrity verification is being done, an attacker might modify the software or data passed to the application, resulting in unexpected consequences. There are mainly two types of vulnerabilities in this category: software integrity failure and data integrity failures. So hence we complete our room. One more room is down. Task is down. Software integrity failure. I think this is basically the practical. Yeah, this is practical. All right. Software integrity failure. So sometimes, user will also add the hash of this file. So once it is downloading on the client, so if somebody have changed it in the transit, even though we are using HTTPS, still if somebody is doing man-in-the-middle attack, we still and change it, the hash of the file will be changed. So question arises: so how the client will see that okay, the hash of the file is changed or not? Okay, so in this case, we are assuming that the source code or the HTML is not modified. Okay, so HTML will have script and the reference of this particular jQuery file and hash as well. So the hash will not be changed. Okay, so once user or the attacker will change the file itself, and that means once we compute the hash on the client side, and that means that if there is any issue, we will reject this particular file and try to download a new one again. Okay, so if this process goes for ever, so that means there will be an issue on the page will not work, and that means that we are preventing the attacker to basically modifying our page using jQuery. All right, let's continue. This is what I brag about, and let's continue with what we have on the TryHackMe. Software integrity failure. Suppose you have a website that uses third-party libraries that are stored in some external servers that are out of your control. While this may sound a bit strange, this is actually a somewhat common practice. Yeah, of course, so we are using CDNs to basically improve the performance of our page, and basically we are putting the load on someone else's infrastructure instead of ours. All right, takes an example: jQuery, a commonly used JavaScript library. If you want, you can include jQuery in your website directly from their servers without actually downloading it by including the following line in the HTML code of your website. That is very true. When a user navigates to your website, its browser will read its HTML code and download jQuery from the specified external source. All right, so we have website, mywebsite.com, and then we have something like a script here. The first request to the website and second request to the website is going to the code jQuery.com. Yeah, so the first request is going to the actual server, and because we get the reference that we have to download the file, we will send another file to code.jQuery domain to get the file here. The problem is that an attacker somehow hacks into the jQuery official repository or man in the middle. They could change the contents of this particular file to inject malicious code. As a result, anyone visiting your website would now pull the malicious code and execute it into their browser unknowingly. This is a software integrity failure, as your website makes no checks against the third-party library to see if it has changed. Modern browsers allow you to specify a hash along the library's URL so that the library code is executed only if the hash of the downloaded file matches the expected value. This security mechanism is called sub-resource integrity, SRI. And you can read more about this on this particular link, which is srehash.org. The correct way to insert the library in your HTML code would be to use SRI and include an integrity hash so that if somehow an attacker is able to modify the library, any client navigating through your website won't execute the modifying version. Here's how that should look in HTML. So let's see. So we have integrity, and we have placed the SH256, and cross origin we put the anonymous. Otherwise we can put that which origin. Yeah, with content security policy we can put in place that which domains are allowed to be referenced in your source code. Okay, so for example, in the content security policy you can mention that code.jquery.com is allowed to be loaded in your website. Then only these domains will be allowed, and anything else with, for example, code 1 or something like that, anything is changed in this domain, the file will not be loaded. You can go to this particular URL, srihash.org, to generate the hashes for any library if needed. What is the h2 SHA-256 hash of this particular? Okay, let's go there, and instead of downloading and generating the hash, we will just which SHA we are looking for, 256. All right, let's change it to 256 hash. So here is the hash we are looking for. Copy, paste, submit. Awesome. So we are 21 minutes into the video and still we are rolling on. Let's continue. Task 20, data integrity failures. All right, data integrity failures. We think of how website applications maintains data or session or user session. Usually when a user logs into an application, we will be assigned some sort of session token that will need to be saved on the browser for as long as the session lasts. This token will be repeated on each subsequent request so that the web application knows who we are. These sessions token can come in many forms but are usually assigned via cookies. Yeah, this is true. Cookies are key value pair that a website or web application will store on the user's browser, and that will be automatically repeated on each request to the website that issued them. For example, user is equal to Susan. For example, if you were creating a webmail application, you could assign a cookie to each user after logging in that contains their username. In subsequent requests, your browser would always send your username in the cookie so that your web application knows what user is connecting. This would be a terrible idea security-wise because, as we mentioned, cookies are stored on the user's browser. Yes, you can even see the cookie in the browser. For example, if you go here and more tools, we need the web developer tools, and application, and we don't have anything here. Okay, what about this one? Right. What if I click on storage? So in the storage we have cookies. As you can see, this is PHP's CSSID. That means somebody is using the app PHP on this particular website, and also it is visible from here. And this is the cookie value after we are logged in. So this is what we are referring to here. Alright, so this would be a terrible idea security wise because, wait a minute. In subsequent requests, your browser would always send your username in the cookies so that your web application knows what user is going to know. This is a terrible idea. It should not be the user itself, right? This would be a terrible idea security wise because, as we mentioned, cookies are stored on the user's browser. So if the user tampers with the cookie and changes the username, they could potentially impersonate someone else and read their emails. This application would suffer from a data integrity failure, and it trusts data that an attacker can tamper with. One solution to this is to use some integrity mechanisms to guarantee that the cookie hasn't been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all the cyber cryptography to provide proof of integrity without you having to bother with it. One such implementation is JSON Web Token JWT. That is very true. JWT are very simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. This idea is that you can generate tokens that you can give your users with the certainty that they won't be able to alter the key value pairs and they pass the integrity check. The structure of the JWT token is formed of three parts. We have header, we have payload, and we have signature. Header is JWT and HS256. Payload is username and something like that, and then the signature of it. The header contains metadata indicating that this is a JWT, and signing algorithm is in use is HS256. The payload contains the key value pair with the data that the web application wants the clients to store. The signature is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match the payload and know that you tampered with JWT. Unlike a simple hash, this signature involves the use of a secret key held by a server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key. That is awesome. Notice that each of three parts of the token is simply plain text encoded with base 64. You can use this online tool to encode and decode base 64. Let's do that. Try decoding the header and payload of the following token. Sure. And that's it. Alright. Let me close all others. We can decode basically. So we have type JWT. Let me zoom in. Username is cast and exp is something like that, and then something at the end. Note this signature contains binary data, so even if you decode it, you won't be able to make much sense of it. We are making sense of it, but yes, this is at the end of the data we are not able to see what is going on. JWT and the non-algorithm. A data integrity failure vulnerability was present on some libraries implementing JWT a while ago. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allowed attackers to bypass the signature validation by changing the two following things in a JWT. Modify the header section of the token so that ALG header would contain the value none. Alright, remove the signature part. Taking the JWT from before as an example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and payload, modifying them as needed and encode them back. Notice how we removed the signature part but kept the dot at the end. Wait a minute. So this is the header and we changed to this one. It sounds pretty simple. Let's walk through the process an attacker would have to follow in an example scenario. Okay, so this is example scenario. Let's open this one. I will close everything else here and just open the website that we need to go with. Try logging in with the application as a guest. What is the guest account password? Okay. What we did exactly here, taking the JWT before example, we want to change the payload so that the user becomes admin. Okay. Try logging in the application as a guest. What is the account? What is the guest account password? Login. Okay, the guest account password is guest. Hello, we are logged in. Okay, wait. Only admin user is allowed to do that. Alright. Let's see in the storage. And here is the session token that we have. Come on, man. I cannot do that. Okay. So this is the session token. What if I just copy the value? Copy. Let's see. Failure to execute atom. The string to be decoded is not completely encoded. So what if we just remove the part from here? Alright, so username is guest, but password is also guest, right? If your login was successful, you should now have a JWT stored on a cookie in your browser. Press F12 to bring out the developer tools. Yeah, we have done so already. What is the name of the website's cookie containing a JWT token? Name of the website? What is the name of the website's cookie? Okay, it is JWT session. JWT session. Alright. Use the knowledge gained in the stars to modify the JWT token so that the application thinks you are an admin user. Alright. So let's change it to... Come on, man. Let me copy this. We need to encode it. And instead of this one, we go with the admin, and here is our base60 code encoded. And here, let me operate in a full browser, full window, so we have a lot of real estate to work with. So I can see what part I need to change. So we need to change the part before the dot, okay? So I change it, enter, and if I refresh it again, either the token or the signature is invalid. What happens? Wait a moment. Okay. Notice we removed the signature part but kept the dot at the end. Okay, so what if we remove the... Come on, man. So we remove the signature and keep the dot at the end. And what if we refresh again? What happened? Either token or its signature is invalid. not able to get it. Wait a minute. Let's try again. Guest. Guest. So we are logged in, right? Okay, so in this case, can I? Yes, we can. Here is the cookie, and this is what we are looking for, basically. And we need to change this particular thing. Decode. No. All right. So we okay. Now I understand. So we don't need to change anything here. We need to take the information after first dot and until the second dot. Come on. All right. So here we go. I took it and paste it here. Now all we need to do is just copy this one and put admin. Now copy this back. Here. Alright, so let's go to the flag again. Okay, it is saying that we haven't done our thing. So what we are missing at the end, this is first dot, and then we have second dot somewhere here. So we will remove everything after the second dot. All right, and then if we access it again, what we are not doing right, guys. I have taken the JWT before an example. If we wanted to change the payload so that the username becomes admin, no signature check is done. We would have to decode the header and payload, modify them as needed. Okay, algorithm should be none. Oh man. Okay. We missed a very basic clue, guys. All right, login. Now we have the cookie. Here we go. Copy this, decode, put it here. We remove the last part, which now will not be used. Here we go. What if I remove the dot as well? Yeah, this makes sense. Now what we do is algorithm, we are using none, and admin, and now this is the string that we are looking for. But where is the dot exactly? Wait a moment. There should be a dot, right? Okay, so let me open up mousepad here. So this is the first one, and sorry, this is the header. Okay, and second one is the so I will take this one and put it in my mouse pad. This is the first part, and then dot. The second part is this one. Let's encode this one as well. Alright, we have the encoded values, and let's put after dot, we'll put this value, and then we'll add on one more dot for the signature. In this case, signature is empty because we are saying that we are not using any algorithm to do any of the things. Let's enter here, let's access the page again, and here is our flag. Awesome, awesome, awesome. So we learned something here. Submit. Awesome. So we have 2 more tasks to go. So once we come back, we're gonna start with the task 21. So we are already 40 minutes past, so thank you guys for joining me. So beware to check out the next video that I will reference over here once I publish the next video. Okay, so thank you guys for joining me. If you like the video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community. We are very few right now. Help us build the community. Share the video with others and ask them to subscribe. Thank you very much, and I will see you in the next video.